In this video, we will be looking at experimental designs. The types of experimental designs include the completely randomized design, the randomized block design, and the matched pairs design. In a completely randomized design, each experimental unit is randomly assigned to a random group to receive a different treatment. Each unit in the same group will receive the same treatment, and at the end of the experiment, you will compare the results from each treatment. Show how a completely randomized design would be used in the following example. A researcher wants to conduct an experiment to determine which environment is best suited for studying: a library, in one's own room, or outside. A total of 30 university students volunteer to participate in the experiment. So we have three treatments: the library, in one's own room, and outside. Since we have three treatments, we will have three groups receiving the treatments. Since there are 30 university students, these 30 subjects will be randomly assigned into three groups to receive the treatments. Since there are 30 people, each group will have 10 people, and at the end of the experiment, we would compare the results from each treatment. Let's say that the researcher believes that gender has an effect on the results. In a case like this, we would use a randomized block design. A randomized block design doesn't immediately randomly assign experimental units to receive treatments. We first assign people into a block based on a characteristic that is expected to influence the response to the treatments. In this example, gender would be the blocking variable. So first, we separate our experimental units based on gender. One block will be for females and one block will be for males. There are 18 females and 12 males. Then, the experimental units in each block will be randomly assigned to three different groups to receive a treatment. So let's make a diagram out of this. We are looking at a randomized block design, and gender was the blocking variable. We started off with 30 university students, and we separated these students into two blocks. One was for males and one was for females. We determined that there were 18 females and 12 males. We will have the females be randomly assigned to three different groups, and each group will have 6 females, and each group will receive different treatments. For the males, we are doing the same thing, except we have 12 males, so we will randomly assign 4 males into each group. And at the end of the experiment, we will compare the results within each block. The last type of experiment we'll talk about is the matched pairs design. In a matched pairs design, we are only comparing two treatments by using the same or similar experimental units. If we are using the same experimental units, we could have an example like this. What type of gasoline is more efficient? Type A gasoline or Type B gasoline? 3 cars will be used in this experiment. Describe how a matched pairs design would be used. If we are using the same experimental units, then each experimental unit will receive both treatments. So we have 3 cars, and each car will receive the 2 treatments, one with Type A gasoline and one with Type B gasoline. We would use the same car for each treatment, and which treatment goes first will be random. So for example, we could drive with Type B gasoline first, then once all the gasoline is finished, we would fill up the car with Type A gasoline using the same quantity, and at the end of the experiment, we would compare the efficiency of the gasoline. There are cases when we can't use the same experimental units for a matched pairs design, and we would have to use similar experimental units. For example, a researcher is trying to determine whether or not sleep deprivation has an effect on test scores. Describe how a matched pairs design would be used. Well, we could try giving both treatments to the same experimental units like we did in the other example. In other words, we could have the same person write the test on 2 different days, one being sleep deprived and the other with sufficient sleep. The problem with this is that we can't have the same subject write the same test because they would know what's on the exam when they write it the second time, so that would be kind of unfair. Instead, we could start off by pairing up students with similar GPAs. So for example, the 2 students with the highest GPAs would be matched up together, and the 2 students with the lowest GPAs would be matched up together. Then, each pair will be split up and randomly assigned to one of the 2 treatments. So for a pair, one person will get the sleep-deprived treatment, and the other person will get a normal amount of sleep. Then, we would compare the results for each pair, and we will also compare all of the results. So for example, if we saw that the sleep-deprived people were consistently getting lower test scores than the people who got a regular amount of sleep, then we can say that sleep deprivation was actually the cause for a bad test score. So let's quickly recap. These are the experimental designs we talked about. In a completely randomized design, each experimental unit is randomly assigned to a random group to receive a different treatment. This is what the diagram would look like. Group N, or treatment N, means you can have any number of groups or treatments. A randomized block design first assigns people into a block based on a characteristic that is expected to influence the response of the experimental units to the treatments. Then, a completely randomized design is performed within each block. This is what the diagram would look like. Block N means that you can have any number of blocks that you want. For a matched pairs design, we saw two scenarios, one that uses the same experimental units and one that uses similar experimental units. Both of these involve the comparison of only two treatments. If you are using the same experimental units, each experimental unit gets both treatments. This is what the simplified diagram would look like. If you are using similar experimental units, we first pair up similar experimental units, then each pair is split up and randomly assigned to one of two treatments. This is what the simplified diagram would look like.